The number of people in the United States aged 65 and over has increased rapidly since 1900 and can be approximated by y equals 3.17 times 1.026 to the x power, where y is the number in millions aged 65 and older and x is the number of years after 1900. Part A. Find the number of people aged 65 and older in 1960 and then in 2012. Part B. In what year were there 31.4 million people aged 65 and older? So for part A, we're going to simply first take each year that we're given, determine how many years after 1900 they are, and substitute that value in for x to see what the corresponding y value would be. So for part A, the first one, in 1960, 1960 is 60 years after 1900. So for the question in 1960, we're going to let x equal 60. And when we substitute that into the equation, we get y equals 3.17 times 1.026 raised to the 60th power. And when we evaluate this with our calculator, we will get y is equal to 14.8 million. Y is equal to 14.8 million. Next, second part to part A, how about in 2012? And in this case, we're going to let x equal 112. 2012 is 112 years after 1900. Making the substitution, we get y equals 3.17 times 1.026 raised to the 112th power, and evaluating with our calculator, we get y is equal to 56.2 million, rounded to the nearest tenth. 56.2 million. Part B, in what year were there 31.4 million people aged 65 and older? So with this problem, we're going to start with our equation. Y equals 3.17 times 1.026 to the x power. And with part B, we're going to let y equal 31.4, and we're going to determine what value of x causes that to happen. So we have 31.4 equals 3.17 times 1.026 to the x power. And to solve this exponential equation for x, we'll first divide both sides of the equation by 3.17. That gives us 9.9 equals 1.026 to the x power. And in order to get the variable out of the exponent position, we'll now take the natural log of both sides. So we have the natural log of 9.9 equals the natural log of 1.026 to the x power. And on the right side, we'll use the power property of logarithms. We'll swing that exponent down in front, making it a coefficient. So this would equal the natural log of 9.9 equals x times the natural log of 1.026. And then to isolate x, we'll divide both sides by the natural log of 1.026, giving us natural log of 9.9 divided by the natural log of 1.026. And when you evaluate this expression on the calculator, you will get that x is approximately equal to 89.3157749. And because we're trying to determine a year, we're going to round this off to the nearest whole number. So we're going to simply say x is approximately equal to 89. And recall x is the number of years after 1900. So the answer to part B, it would be the year 1989.